All right, let's discuss about arbitration in CAN bus. So before going to how arbitration works, let's have a quick look on how the CAN frame looks like. So typically we will be focusing on the first two elements of the CAN frame, which is the start of frame, which is just a single bit. And then we have the arbitration field, which includes an identifier, which is 11 bits, and an RTR, which is 1 bit. Now, typically in a CAN bus, so the recessive state is something where the CAN high and the CAN low are at 2.5 volts. And as per the logic, the recessive state is logic 1. And when we have the dominant state, that is when we have the CAN low, which is pulled to 1.5 volts, and CAN high, which is pulled to 3.5 volts. So as you know, we have two-wire communication in CAN bus, and the CAN high with respect to the ground and the CAN low with respect to the ground will have those voltages, so 3.5 and the 1.5. So this is the state where we call it as a dominant state. And the dominant state by logic is having a logic 0. So when we have a start of frame which is a dominant bit, that means we are in this particular state where the CAN high and the CAN low are in these respective voltage levels. Now, in terms of how arbitration works in CAN bus, so why do we need arbitration in the first place? So for example, um, three different ECUs or three different nodes want to send their respective PDUs at the same time, and you want to avoid the conflict for sure. So how do you prioritize between these three particular nodes? So what can you do? So typically for any node or any ECU to be sending its PDU, it has to wait for the CAN bus to become idle, right? So only when the CAN bus is idle, it can start sending this SOF as we discussed. So the start of frame, which is always a 1 bit, which is always a dominant 1 bit. So that means it's a logic 0. So once this SOF is sent, so the node starts sending its identifier. So the identifier is going to be 11-bit identifier for a standard CAN frame. So then what happens? So let's say, for example, at this instant, 3 or 4 different nodes have sent the SOF at the same instant. And now we have to decide which of these particular nodes and the respective PDUs get the priority. So that's when we start looking at the identifier, so in which the arbitration, which we will shortly discuss, will take place. So the node which wins the arbitration will go ahead and send the rest of the frame onto the CAN bus. It will broadcast its entire frame until the EOF, the end of frame. But the remaining nodes which have lost out in the arbitration have gone back to its original state and waiting for the bus to become idle again. So the nodes which lost, they go through the process again until they win the arbitration. Now here comes the question about arbitration. So it is actually pretty simple. So when the identifier is being sent, so it is always checking bitwise which particular node starts to get the prioritization. So a simple example here, so let's say I've taken three nodes, three 11-bit identifiers respectively. So we start looking at, so each of these three nodes have already sent their start of frame. SOF is already sent, and then the node 1, node 2, node 3 are trying to put these particular identifiers onto the CAN bus. So what happens? So at the beginning, node 1, 2, and 3 are all in recessive state. So the CAN bus is at 2.5 volt, nothing is changing. Then we go to the second bit, node 1, 2, and 3 are again sending the recessive bits, nothing is going to change. When it comes to the third bit, the node 1 is sending the recessive bit, whereas the nodes 2 and nodes 3 are sending the dominant bit. So which means here the node 1 has lost out in arbitration. So what happens? It goes back to this particular state and it is waiting for the bus to become idle again. And then amongst node 2 and node 3, what we see as the fourth bit, so node 2 is getting a 0, whereas node 3 is trying to send a 1. That's the identifier which is defined. So by the way, these are not the identifiers which are changing. So when you design a CAN bus, you design a particular node to have a particular ID or a particular PDU to have a particular ID. So it's already pre-designed. So let's say I would uh, think of two different signals. So one of the signal is of really high priority. For example, in automotive world, for example, a crash detection. That for me is the highest priority. So what would I do is I would straight away start with the dominant bits. I would always ensure that this particular crash signal is being transmitted the first. So it's all pre-designed. It's not something which is variable. So it's, as I said, it's dependent on the identifier which is constant to a PDU. So yeah, coming back, so the fourth bit, so this is dominant and the node 3 is recessive, so which means the node 3 will lose the arbitration, go back to the stage 1, whereas the node 2 wins the arbitration and sends the end of the frame. So yeah, that's how arbitration works in CAN bus.